Okay, today's class is two-port networks. Two-port network. So basically, port means two-terminal pair. This is one port. This is port 1, 1 prime, 2 and 2 prime. So two ports are there, therefore we call it as two-port. And port is described with voltage and current. Port 2, V2 and I2. We can also add third port V3, I3, fourth port V4, I4, like that n number of ports. If we remove second port, it is as only one port network. Minimum number of ports needed is one. Maximum can be any number. But as per this syllabus, we study only two port networks. And port to one, any port is described with the voltage and the current. The currents, whatever direction we are showing is a conventional. Current entering is positive convention. Here also entering is positive convention. So port means pair of wires is a port. We can apply voltage, we can take the voltage. We can send current, we can also take the current. That's why it is called as a port. You can apply, you can take. Now, the relationship between or among all the parameters, V1, V2 in terms of I1, I2, I1, I2 in terms of V1, V2, like that, different parameters are there. So we'll start with Z parameter. Z parameters. So what is Z parameter is V1 is equal to Z11 I1 plus Z12 I2. V2 equal to Z21 I1 plus Z22 I2. So V1, V2 in terms of Z1, Z2. This V1, V2 named as dependent variables. Dependent variables. Whereas I1, I2 independent variables. Okay, so how to find these parameters? To find Z11, how to find Z11 V1 by I1, V1 by I1 when I2 equal to 0. So this is also named as input impedance when output port. Generally we call this is output port. This is input port. So current 0 means open. When output port is open. Current 0 means open. So after Z11 we find out Z21. Z21 is V2 by I1 when I2 equal to 0. V2 by I1, it is a transfer impedance when output port is open. Then we'll find Z22. Z22 is V2 by I2 when I1 equal to 0. So it is output impedance when input port is open. Input port is open. Input port is open. Then last one Z12. Is V1 by I2 when I1 equal to 0. So this is also output impedance, not output, transfer impedance when input port is open. Input port is open. So we are finding all these things either by opening input port or output port. Therefore, another name is, what is the another name of this? Open circuit parameters. Open circuit parameters. We are finding either opening input port or output port. There is also another name, impedance parameters. Impedance parameters. So Z is a impedance, na? Why notation Z is used? It's voltage by current is a impedance, so Z is used. That's why it is also named as impedance parameters. We can also write in matrix form. Matrix form like this: V1, V2 is equal to Z11, Z12, Z21, Z22. So 1 means matrix, first row, first column. So that is the meaning of matrix notation. Here I1, I2. So like this we can write. So Z parameters definition over. After Z, Y parameters. Y parameters. Y parameters. Or shortcut parameters. Short parameters. Or admittance parameters. These are the three different names. So here I1, I2 expressed in terms of V1, V2. So Y11 V1 plus Y12 V2. Y21 V1 plus Y22 V2. So I1, I2 in terms of V1, V2. And as usual, I1, I2 are dependent variables. V1, V2 are independent variables. What is Y11 named as? So I am not writing again. Y11 is input admittance. Input admittance when output is short. V20 na output is short. And Y21 transfer admittance when output is short. And what is Y22? Output admittance when input is short. What is Y12? Transfer admittance when V1 is short. So similar concept. But always we find this order. We find this first, and this second, this third, this fourth. Why we find these two at a time? Because both the cases V2 0. Later we find these two making V1 0. So 1 1 2 1 will form one set. 2 2 1 2 will form another set. So that's how we find any parameter. So zy over, we can also write y in matrix form. So h parameter. H stands for hybrid. Why that word hybrid came? Port 1 V1 and port 2 I2. Voltage in port 1, current in port 2. That's on hybrid. Hybrid is a mixture of ports as well as variables. Here voltage, here current. So V1 equal to H11 I1 plus H12 P2. Then I2 equal to H21 I1 plus H22 P2. So what is H11? Is a input impedance. H11 is input impedance and output is short. So it is similar to H2 HIE, the common emitter amplifier, E for common emitter, I for impedance, input impedance. Then what is H21? I2 by I1. I2 by I1, forward current gain. So this is similar to HFE. H22, output admittance when input is open. So it is similar to HOE. This one V1 by V2. V2 by V1 is forward, V1 by V2 is reverse. So HRE, reverse voltage gain, forward current gain, input impedance, output admittance. Admittance units are mhos. Impedance units are ohm. No units for voltage gain as well as current gain. But how to draw the equivalent circuit? This equivalent circuit is very important. Most of the books, they don't discuss this. So first voltage form. Voltage form is always in series. So this is H11, current I1. So we are applying voltage V1. So V1 is equal to H11 I1 plus this is an voltage. What is this value? H1 to V2. So when I am writing a mesh equation, we get same thing. So V1 equal to H11 I1 plus H1 to V2. So this is first equation. What is second equation is current form. Current form means nodal. Nodal means parallel. So here we have to show parallel. So V2 I2 common anyway. And this is H22. So when you write nodal equation, I2 is equal to what? H21 I1 is a current that should go down. H21 I1. Then H2. H22 moves. So what is this current to downward current is H22 into V2. So I2 is entering, H21 I1 leaving, H2 to V2 also leaving, entering equal to leaving. So here what I have written? Nodal. So when I write nodal, I get second equation. When I write mesh, I get a first equation. So normal practice is to join this. So this is the equivalent circuit. Equivalent of H parameters. Of H parameters. So like this easily we can draw the equivalent circuit. How to draw the equivalent circuit for Y? Y both are current form. Na? That means both are in parallel. So both are in parallel. So this is Y11. Is V1 I1. So I1 current is equal to Y11 V1 plus what is this current Y1 to V2. Similarly, will be parallel. So this is at y2. This current is y21 v1. y21 v1. So what is I2 is equal to y21 v1 plus y22 v. So like this is the equivalent circuit of y parameter. Like that, even for Z also we can draw equivalent for Z. Z is V1, V2 in terms of I1, I2. So both are voltage form. Both are in series. These equivalent circuits will be helpful in solving special problems. So that's why I am drawing. So V1 is equal to Z11 I1 plus Z12 I2. V2 I2. So this is Z22. Z21 I1. So when we write equation for V2, you get what? Z21 I1 plus Z22 I2. Generally, if you write this equation, you get same. This line not necessary to join, but a normal practice to join. What is the current in this? 0. Current will not flow here. If it is flowing, where is the way to come back? So it will not flow. So since current is not flowing, I can open. But even though it is open, this left side circuit, right side circuit dependent on each other. So if you see here Z12 I2, I2 is here na. Z21 I1, I1 is left side. So they are dependent. That is symbol. So I have shown how to draw the equivalent circuit for Z, Y, H. So H parameter or hybrid parameters. Next to G parameters. G parameters are inverse hybrid. Inverse H parameter. Inverse H. So why this is called as inverse H? Voltage current is swapped. In place of V1, you write I1. Now G11, I1 is replaced with V1 plus G12, V2 become I2. Then I2 is replaced with V2, G21 V1 plus G22 I2. Just in place of voltage, you write current. In place of current, you write voltage. Why inverse H is indicated with G? The letter H we write like this. What is inverse of H? This tail will come down. So letter G looks like inverse of H. That's the reason letter G is used for inverse hybrid parameters. So same way you can draw the equivalent circuit for this homework. First one is current form. So parallel will come. Second is voltage is series form. Left side parallel form, right side series form. Like that you can write. Next we have a ABCD parameters. ABCD. So V1, V2 in terms of I1, I2. Sorry, V1, I1, V1, I1. So A V2 minus B I2. C V2 minus D I2. ABCD parameters or T parameters. T parameters. T for transmission. Transmission parameters. Why this negative sign is used here is, to take any transmission line, when V1 is applied, V1 source is applied, current will flow like this. It is terminated with some load, a load of ZL. So what is the voltage here? V2. V2 is the drop now. So current will flow like this now. But as I told you, current entering into the port is plus. What is coming out to minus side. So I am writing in terms of V2 and minus I2. That's why this negative sign came like that. So that is the reason. So T parameters are ABCD parameters. Inverse ABCD also there. Last one. Inverse ABCD parameters. So this is also indicated with A prime, B prime, C prime, D. So how to write them? V2, I2 in terms of V1, I1. So A prime V1 minus B prime I1. C prime V1 minus D prime I1. Just prime attach another. So V2, I2 expressed in terms of V1, I1. There is no equivalent circuit for ABCD and inverse ABCD. Not possible to draw equivalent circuit for ABCD as well as inverse ABCD. So total we have 6 parameters. This 6, total 4 variables. What are those 4? V1, I1, V2, I2. From these 4, 2 to how many ways we can select? 4C2 is equal to 6. 6 combinations. So total 6 parameters will come. This name is assigned based on its behavior. Voltage to current always, so Z. Current to voltage always Y. Here voltage random is there, mixed, so hybrid. Then voltage current is swapped, inverse hybrid. Input in terms of output ABCD, then output in terms of inputs is inverse. So like that, all the relations we are coming across. What is the use of this two-port network? We are understanding the relationship among all the 4 parameters. How V1, V2 connected to I1, I2, how I1, I2 connected or related with V1, V2 and so on. What is the use of two-port networks? This you already studied now, H parameters, hybrid parameters, common emitter amplifier, hybrid model. equivalent circuit. There you already studied in terms of HIE, HRE, HFE, HOE. If it is a common base, HIB, HRB, HFB, HOB, like that. So easily you can draw the equivalent circuit, easily you can write the equation. We also call it as a small signal model. So this you are using this in analyzing the transistor. And ABCD parameters are used in analyzing a transmission line. So T parameters used in analyzing transmission lines. So, but by and large, we have a 6, but those two are already we are using in some purpose or some applications. So this is one basic definition of two-port. Next, we'll take relationship